Do you want to successfully complete the C165 Objective Assessment exam? Then you are in the right place. Our website provides a list of questions and answers for your success in the C165 OA exam for free. We understand that acing your OA exam can be quite challenging. That's why we provide completely free exam guides and practice questions for you. In this video, we will cover questions from scientific methodology, forces and motion, universal gravitation, forms of energy, matter and changes. So let's get started. 1. A researcher wants to determine if fertilizer type affects plant growth. So they apply different fertilizers to separate plant groups while keeping water, sunlight and soil conditions identical across all groups. What is the primary purpose of keeping these other conditions identical throughout the experiment? A. To eliminate dependent variables. B. To increase the number of trials. C. To control variables not under study. D. To maximize the fertilizer effects. Do you know the answer? Correct answer, C. To control variables not under study. Explanation. Option C is correct because keeping conditions identical ensures that only the independent variable being studied can affect the outcome, preventing false relationships between variables. Option A is incorrect because the dependent variable is the measured outcome of the plant growth, which cannot be eliminated since it represents the results being observed. Option B is incorrect because keeping conditions identical relates to variable control, not to increasing the number of experimental trials or repetitions conducted. Option D is incorrect because the purpose is to isolate the effect of the independent variable, not to artificially enhance or maximize any particular outcome. Let's talk about why scientists obsess over keeping conditions the same in experiments. When a researcher tests whether fertilizer type affects plant growth, they're looking at one thing: the relationship between fertilizer and growth. But here's the problem. Plants respond to everything: water, sunlight, soil quality, temperature. If any of those change between groups, you can't tell what actually caused the growth difference. Was it the fertilizer? Was it extra sunlight? You'd never know. That's why controlling variables matters. By keeping water, sunlight and soil identical across all groups, the researcher isolates the independent variable, the fertilizer. So any differences in plant growth must come from that one factor. The dependent variable is the outcome you measure, which is plant growth here. You can't eliminate that. It's the whole point. And this isn't about maximizing effects or running more trials. It's about making sure your results actually mean something. Here's a WGU C165 OA exam tip for you. When you see a question about keeping conditions identical or constant, think controlling variables. The keyword identical conditions signals variable control. Quick recall hook. Identical equals isolation. Identical conditions isolate your variable. 2. During an experiment measuring how temperature affects the rate at which sugar dissolves in water, a student accidentally uses different amounts of water for each trial without realizing the inconsistency. How would this oversight most likely impact the experiment? A. The results become unreliable. B. The temperature readings change. C. Sugar dissolves more quickly. D. The experiment becomes observational. Do you know the answer? Correct answer, A. The results become unreliable. Explanation. Option A is correct because using different water amounts introduces an uncontrolled variable, making it impossible to determine whether dissolution differences resulted from temperature or water volume. Option B is incorrect because the amount of water used does not directly alter the temperature readings taken during the experiment, though it affects dissolution. Option C is incorrect because varying water amounts could either speed up or slow down dissolution unpredictably, not guarantee faster dissolution across all trials. Option D is incorrect because the experiment remains controlled in structure even with errors. The oversight creates flawed data, not a different methodology entirely. Here's a classic mistake that ruins experiments. A student wants to measure how temperature affects sugar dissolving in water. Good question, clear setup, but they accidentally use different amounts of water in each trial without realizing it. Now you've got a mess. Did the sugar dissolve faster because the water was warmer? Or because there was more water? You can't separate the two. This is what scientists call an uncontrolled variable. Water amount should have stayed constant, but it didn't. The results become unreliable because you can't trust what caused the differences you observed. The experiment doesn't suddenly become observational. It's still a controlled experiment in structure, just a flawed one. And no, the temperature readings don't change because you use different water amounts. Here's a WGU C165 OA exam tip for you. When a question describes an experimental error involving inconsistent conditions, the answer almost always involves reliability or validity problems. The keyword accidentally or without realizing signals an uncontrolled variable. Quick recall hook. Inconsistent means unreliable. If conditions vary, results can't be trusted. 3. A scientist measures neighborhood temperature variations by recording readings at noon daily for 1 year from a single location in their front yard near a large tree. A colleague suggests the data may not accurately represent the neighborhood. Which factor most significantly threatens the validity of the collected data? A. The measurement time is inconsistent. B. Hidden variables affect the readings. C. The year-long period is too short. D. Noon is an inappropriate measurement time. What do you think is the answer? Correct answer, B. Hidden variables affect the readings. Explanation. Option B is correct because the tree provides shade that may lower temperatures compared to other neighborhood locations, creating a hidden variable affecting measurement accuracy. Option A is incorrect because the scientist is measuring consistently at noon each day. The measurement timing is actually consistent throughout the year-long study. Option C is incorrect because 1 year is actually a sufficient duration to capture seasonal temperature variations. The issue is location, representativeness, not time span. Option D is incorrect because noon is a valid and commonly used time for daily temperature measurements. The problem lies in the measurement location, not timing. A scientist measures neighborhood temperature by recording readings at noon every day for a year. Sounds thorough, right? One location, consistent timing, a whole year of data. But there's a problem the colleague spotted. The measurement spot is near a large tree. That tree provides shade, which likely lowers temperatures compared to sunny spots elsewhere in the neighborhood. This is a hidden variable, also called a confounding variable. The data isn't wrong per se, it accurately represents that one shady spot, but it doesn't represent the neighborhood. The measurement timing is actually consistent. Noon every day. A year's plenty long to capture seasonal changes. And noon is a perfectly standard time for temperature readings. The issue is purely about location. That tree creates conditions that don't exist everywhere else. Here's a WGU C165 OA exam tip for you. When a question mentions an environmental feature near a measurement location, think hidden variable, trees, buildings, water bodies. These create microclimates that affect readings. Quick recall hook, hidden in plain sight. Environmental features hide variables that skew data. 4. Astronomers studying how stars form cannot create a star in a laboratory to observe the process directly. Instead, they observe hydrogen clouds at various stages of star formation throughout the universe to support their hypotheses. What type of scientific investigation does this approach represent? A. Controlled experimentation. B. Mathematical modelling. C. Computer simulation. D. Observational study. What do you think is the answer? Correct answer, D. Observational study. Explanation: option D is correct because astronomers are observing natural systems as they exist without manipulating or changing them, which defines observational scientific investigation methodology. Option A is incorrect because controlled experiments require manipulating an independent variable while holding others constant, which is impossible with star formation processes. Option B is incorrect because while astronomers may use mathematical models, the described approach specifically involves direct observation of natural phenomena occurring in space. Option C is incorrect because the astronomers are conducting real observations of actual phenomena in space, not running simulated scenarios on computer systems. Astronomers want to understand how stars form. Problem is, you can't exactly create a star in a lab. Stars are massive, take millions of years to develop, and require conditions impossible to replicate on Earth. So what do scientists do? They observe. They look at hydrogen clouds throughout the universe that are at different stages of star formation, some just beginning to collapse, some partway through, some nearly complete. By studying many examples at different stages, they piece together the process. This is observational science. No manipulation, no controlled experiments, just careful watching and recording of natural phenomena as they exist. It's different from a controlled experiment where you change one variable and measure the result. It's not mathematical modelling or computer simulation either, though astronomers use those too. The approach described is specifically about direct observation of real phenomena in space. Here's a WGU C165 OA exam tip for you. When a question says scientists cannot manipulate or cannot create something in a lab, the answer is usually observational study. The keywords observe, watch, or study natural systems signal this methodology. Quick recall hook: can't touch it, just watch it. If you can't manipulate it, you observe it. 5. A friend claims they have developed a new health treatment that works through mechanisms that cannot be tested or measured using any known scientific instruments or methods. Based on essential attributes of science, what concern should this claim raise? A. The claim lacks peer review. B. The treatment lacks funding. C. The claim is not testable. D. The results are preliminary. What do you think is the answer? Correct answer: C. The claim is not testable. Explanation: option C is correct because testability is an essential attribute of science. Claims that cannot be tested by any known method fall outside the boundaries of scientific investigation. Option A is incorrect because while peer review is valuable, it is not as fundamental as testability. Some valid science proceeds before formal peer review occurs. Option B is incorrect because funding status has no bearing on whether something qualifies as science. Many valid scientific investigations operate with limited financial resources. Option D is incorrect because the issue is not that results are early or incomplete, but that the underlying mechanisms cannot be tested at all using scientific methods. Your friend claims they've invented a health treatment that works through mechanisms no scientific instrument can test or measure. Red flag. Testability is the foundation of science. If you can't test a claim, if there's no possible experiment, measurement, or observation that could prove it right or wrong, it's not science. It might be philosophy, belief, or speculation, but it's outside the boundaries of scientific inquiry. Peer review matters, sure, but plenty of valid science exists before formal peer review happens. That's not the core issue here. Funding has nothing to do with whether something qualifies as science. Some of the best research happens on shoestring budgets. And this isn't about results being preliminary or incomplete. The problem is more fundamental. The claimed mechanisms can't be tested at all. No test means no science. Here's a WGU C165 OA exam tip for you. When a question mentions something that cannot be tested or cannot be measured, testability is your answer. This is a core requirement of the scientific method. Quick recall hook: no test, no science. If you can't test it, it's not scientific. 6. Engineers need to test how air will flow around a new aircraft design before building the actual plane. They construct a smaller version of the aircraft and place it in a controlled wind environment where sensors measure aerodynamic forces and pressures. What type of scientific model does this approach represent? A. Conceptual model. B. Physical model. C. Mathematical model. D. Computer simulation. Can you guess the answer? Correct answer, B. Physical model. Explanation: option B is correct because a wind tunnel uses a scaled-down tangible replica of the actual object to study aerodynamic properties under controlled reproducible conditions. Option A is incorrect because conceptual models are mental or visual representations used to understand abstract ideas, not tangible replicas used for physical testing. Option C is incorrect because mathematical models use formulas and equations to represent physical properties, not physical replicas tested in controlled environments. Option D is incorrect because while computers may record wind tunnel data, the primary investigative tool is the physical scaled model, not a digital simulation. Engineers need to know how air flows around an aircraft before building the real thing. So they build a smaller version and stick it in a wind tunnel with sensors measuring aerodynamic forces. This is a physical model, a tangible, scaled-down replica you can actually touch and test. It's not a conceptual model, which would be a mental picture or diagram explaining an idea. It's not a mathematical model, which would be equations predicting airflow. And it's not a computer simulation, even though computers might record the wind tunnel data. The key is that the primary tool is a real physical object being tested in real conditions. Physical models let engineers see actual behaviour rather than predicted behaviour. You learn things in wind tunnels that equations might miss. Here's a WGU C165 OA exam tip for you. When a question describes a scaled replica being tested in real conditions, that's a physical model. Keywords like smaller version, scaled down, and controlled environment point to physical models. Quick recall hook. If you can touch it, it's physical. Tangible replicas are physical models. 7. Early scientists developed the plum pudding model of the atom, depicting electrons embedded within a uniform sphere of positive charge like raisins in pudding. This model successfully explained why atoms are electrically neutral, but was later replaced. What does this historical progression best illustrate about scientific models? A. Models must include all observations. B. Incorrect models have no value. C. Models evolve with new knowledge. D. Simple models always fail eventually. Do you know the answer? Correct answer, C. Models evolve with new knowledge. Explanation. Option C is correct because the plum pudding model served its purpose until new discoveries required a more comprehensive model, demonstrating how scientific understanding progresses. Option A is incorrect because good models intentionally include only relevant features for their purpose. The plum pudding model successfully explained atomic neutrality without comprehensive detail. Option B is incorrect because the plum pudding model had significant value by explaining atomic neutrality and advancing understanding before being superseded by improved models. Option D is incorrect because simplicity itself does not cause failure. Models are replaced when they cannot explain new observations, regardless of their complexity level. The plum pudding model pictured electrons scattered through a uniform blob of positive charge, like raisins in pudding. It explains something important: why atoms are electrically neutral. Positive and negative charges balanced out. But then Rutherford shot particles at gold foil, and some bounced straight back. The plum pudding model couldn't explain that. So scientists developed a new model with a dense positive nucleus. Here's what matters. The plum pudding model wasn't worthless. It served its purpose for years and advanced understanding. Models don't need to be perfect. They need to work for their specific purpose until new evidence demands something better. That's how science progresses. Models evolve. They're not simple or complex by nature of being temporary. They get replaced when they can't explain new observations. Here's a WGU C165 OA exam tip for you. When a question describes an old model being replaced, the answer involves evolution of understanding, not failure. The phrase "was later replaced" signals model evolution. Quick recall hook. Models evolve, they don't fail. Replacement means progress, not worthlessness. 8. Christopher Columbus used the spherical Earth model to calculate the distance to India for his voyage, but he significantly underestimated the journey length because he used incorrect values for the Earth's radius. What does this situation demonstrate about scientific models? A. Spherical models are inherently flawed. B. Model parameters must be accurate. C. Voyages require multiple models. D. Mathematical calculations always fail. What do you think is the answer? Correct answer: B. Model parameters must be accurate. Explanation: Option B is correct because Columbus used the correct model, but with incorrect parameter values, demonstrating that even valid models produce wrong predictions when input values are inaccurate. Option A is incorrect because the spherical Earth model is fundamentally correct and is still used today for navigation. The flaw was in the radius value used, not the model itself. Option C is incorrect because the spherical model was sufficient for the voyage calculation. The issue was parameter accuracy, not the need for additional complementary models. Option D is incorrect because mathematical calculations based on models work correctly when proper parameters are used. Columbus's error was in the input values, not the calculation method. Columbus knew Earth was round. That model was correct. He used it to calculate the distance to India, but he got the Earth's radius wrong. Way wrong. He thought Earth was much smaller than it actually is, so he expected a short trip west to reach Asia. Instead, he bumped into the Americas. The spherical Earth model is still correct today. Navigators use it constantly. The problem wasn't the model, it was the numbers Columbus plugged into it. Parameters matter. A perfect equation with bad inputs gives bad outputs. You need both a valid model and accurate values for that model to produce useful predictions. This isn't about needing multiple models or math being unreliable. It's about garbage in, garbage out. Here's a WGU C165 OA exam tip for you. When a question mentions correct models with wrong results, look for parameter accuracy issues. The phrase "used incorrect values" is your signal. Quick recall hook. Right model, wrong numbers. Bad parameters break good models. 9. Scientists cannot directly observe the centre of Earth because it is completely inaccessible. Yet they have developed detailed understanding of its composition and structure. How do scientists study phenomena that cannot be directly observed? A. They ignore such phenomena entirely. B. They wait for technology improvements. C. They rely solely on historical records. D. They create models based on evidence. Do you know the answer? Correct answer: D. They create models based on evidence. Explanation: Option D is correct because scientists develop models based on indirect evidence, like seismic waves and gravitational measurements, to understand inaccessible phenomena like Earth's interior. Option A is incorrect because science actively pursues understanding of phenomena that cannot be directly observed through modelling and indirect evidence analysis approaches. Option B is incorrect because while technology advances help, scientists do not simply wait but instead develop models using currently available indirect evidence and measurement techniques. Option C is incorrect because understanding Earth's interior relies on ongoing scientific measurements and model development, not primarily on historical documentation or records. Nobody has visited Earth's core. It's about 6,400 kilometers down, way hotter than the surface of the sun and under crushing pressure. Direct observation is impossible. So how do we know what's down there? Models based on evidence. Seismic waves from earthquakes travel through Earth and change speed depending on what they pass through. Scientists measure those waves at the surface and work backward to figure out what's inside, like using an ultrasound to see inside a body. Gravitational measurements help too, density calculations. All indirect evidence that builds a picture of what we can't directly see. Scientists don't just ignore things they can't touch. They don't sit around waiting for technology to catch up. They use available evidence to construct models that explain observations and make testable predictions. Here's a WGU C165 OA exam tip for you. When a question asks how scientists study inaccessible phenomena, the answer is models based on indirect evidence. The word inaccessible, or cannot directly observe, points to modelling. Quick recall hook: can't go there, model it. Indirect evidence builds models of the inaccessible. 10. Scientists use supercomputers to model the formation and evolution of the universe, incorporating trillions of pieces of information about particles and their interactions. When the model predicts outcomes that contradict actual observations of the present universe, what step must scientists take next? A. Accept the model predictions. B. Dismiss the conflicting observations. C. Modify the model and rerun it. D. Conclude the universe is unknowable. Can you guess the answer? Correct answer: C. Modify the model and rerun it. Explanation: option C is correct because when model predictions contradict observations, scientists must adjust the model parameters or assumptions and run new simulations until predictions match reality. Option A is incorrect because scientific models must ultimately align with observed reality. Accepting predictions that contradict observations would undermine the model's validity and usefulness. Option B is incorrect because observations of the actual universe represent empirical evidence that models must explain. Dismissing observations violates fundamental scientific methodology. Option D is incorrect because contradictions between models and observations represent opportunities for refinement and deeper understanding, not evidence that phenomena cannot be understood. Scientists use supercomputers to simulate universe formation. They plug in everything known about particles and forces, run the simulation forward billions of years, and see what happens. If the simulated universe looks like our actual universe, same galaxy distributions, same cosmic structures, the model is probably on the right track. But what if it doesn't match? What if the simulation produces something that contradicts what we actually observe? You don't accept the model anyway. You don't dismiss your observations of reality. And you definitely don't throw up your hands and declare the universe unknowable. You modify the model, adjust assumptions, change parameters, run it again. This is iterative refinement, the standard scientific process for complex modelling. Keep testing until predictions match observations. Here's a WGU C165 OA exam tip for you. When model predictions contradict observations, scientists modify and rerun models. The keyword contradict signals the need for model adjustment. Quick recall hook: contradict means correct. When models clash with reality, fix the model. 11. Two workers are pushing a heavy crate in the same direction along a warehouse floor. One worker pushes with 15 newtons of force, while the other pushes with 20 newtons of force in the same direction. What is the net force acting on the crate from their combined effort? A. 5 newtons in the pushing direction. B. 35 newtons in the pushing direction. C. 20 newtons opposing the motion. D. 0 newtons since forces cancel. Do you know the answer? Correct answer: B. 35 newtons in the pushing direction. Explanation: option B is correct because forces acting in the same direction on the same object add together, producing a net force equal to the sum of the individual forces. Option A is incorrect because subtraction is used when forces act in opposite directions, not when they act in the same direction, as in this scenario. Option C is incorrect because both workers are pushing in the same direction, not opposing each other, so the net force supports motion rather than opposing it. Option D is incorrect because forces only cancel when they are equal in magnitude and opposite in direction. These forces act in the same direction and add together. Two workers push a crate in the same direction. One pushes with 15 newtons, the other with 20 newtons. What's the total force on the crate? This is straightforward vector addition for forces in the same direction. Just add them up. 15 plus 20 equals 35 newtons, all pushing the same way. You only subtract forces when they point in opposite directions. When forces align, they combine. The forces don't cancel because they're not opposing each other. And neither worker is pushing against the motion. Both are pushing together, so the crate experiences the combined force of both efforts. Here's a WGU C165 OA exam tip for you. Same direction means add the forces. Opposite direction means subtract. The phrase in the same direction is your cue to add. Quick recall hook, same way, some away. Forces in the same direction add together. 12. A coffee mug sits motionless on a kitchen table. Gravity pulls the mug downward, yet the mug does not fall through the table or float upward. What best explains why the mug remains stationary despite the gravitational force acting upon it? A. Gravity is too weak to affect mugs. B. Air pressure holds the mug still. C. The mug has no mass to attract. D. The table exerts an upward force. Can you guess the answer? Correct answer. D. The table exerts an upward force. Explanation. Option D is correct because the table pushes upward on the mug with a force equal to the mug's weight, creating balanced forces that result in zero net force. Option A is incorrect because gravity affects all objects with mass, including coffee mugs. The gravitational force on the mug is simply balanced by another force. Option B is incorrect because while air pressure exists, the primary force balancing gravity on a stationary object on a surface is the normal force from that surface. Option C is incorrect because all physical objects, including coffee mugs, have mass. The mug's mass is precisely why gravity exerts a downward force upon it. A coffee mug sits on a table. Gravity pulls it down. Yet it doesn't fall through the table or float away. Why? Because the table pushes back. This upward push is called the normal force. Normal meaning perpendicular to the surface, not ordinary. The table exerts a force exactly equal to the mug's weight, but in the opposite direction. Gravity down, table up, both equal. The forces balance. Net force equals zero. No acceleration. The mug stays put. Gravity definitely affects the mug, that's why it has weight. Air pressure exists but isn't what's keeping the mug stationary. And the mug absolutely has mass. The key concept is force balance. When all forces on an object sum to zero, the object doesn't accelerate. Here's a WGU C165 OA exam tip for you. When an object is stationary on a surface, the surface provides normal force balancing gravity. Look for phrases like remains stationary or does not move as signals for balanced forces. Quick recall hook. Table pushes back. Surfaces exert normal force equal to weight. 13. You and a friend are both pushing a shopping cart from opposite ends. You push forward with 25 newtons, while your friend pushes backward with 20 newtons. The cart is also subject to gravity, pushing down and the floor pushing up. Assuming vertical forces are balanced, what happens to the cart? A. It accelerates backward. B. It remains completely stationary. C. It moves forward with acceleration. D. It floats upward off the floor. What do you think is the answer? Correct answer, C. It moves forward with acceleration. Explanation. Option C is correct because the horizontal forces are unbalanced with a net force of 5 newtons forward, causing the cart to accelerate in the forward direction. Option A is incorrect because your forward push of 25 newtons exceeds your friend's backward push of 20 newtons, resulting in net force in your direction. Option B is incorrect because stationary objects require all forces to be balanced. The unequal horizontal forces create a non-zero net force, causing acceleration. Option D is incorrect because the vertical forces are stated to be balanced, meaning gravity and the floor's upward force cancel each other, keeping the cart grounded. You and a friend push a shopping cart from opposite ends. You push forward with 25 newtons. Your friend pushes backward with 20 newtons. The vertical forces, gravity pulling down, floor pushing up, are balanced. So what happens horizontally? You've got unequal forces in opposite directions. 25 forward minus 20 backward equals 5 newtons net force in the forward direction. Unbalanced force means acceleration. The cart speeds up in your direction. It doesn't stay still because the forces aren't equal. It doesn't go backward because your force is larger. It doesn't float because vertical forces are balanced. That's a separate calculation that keeps it grounded. Here's a WGU C165 OA exam tip for you. When forces act in opposite directions, subtract them to find net force. The larger force determines the direction of motion. Quick recall hook. Bigger wins. When opposing forces differ, the larger one determines direction. 14. A driver wants their car to slow down while travelling forward on a straight road. According to the relationship between force and acceleration, in which direction must the driver apply a braking force to reduce the car's speed? A. Opposite to the direction of motion. B. In the same direction as motion. C. Perpendicular to the car's path. D. Upward against gravity. What do you think is the answer? Correct answer, A. Opposite to the direction of motion. Explanation. Option A is correct, because to slow an object down, the force must act opposite to the direction of motion, causing negative acceleration or deceleration. Option B is incorrect because applying force in the same direction as motion would cause the car to speed up, not slow down as the driver intends. Option C is incorrect because perpendicular force would cause the car to turn rather than slow down. Deceleration requires force opposing the motion direction. Option D is incorrect because upward force would affect vertical motion, not the horizontal forward motion of the car that the driver wants to reduce. You're driving forward and want to slow down. Which direction should the braking force act? Opposite to your motion. To reduce speed, to decelerate, you need force working against your current velocity. Brake pads create friction against the wheel's rotation, applying force backward while you're moving forward. That opposing force slows you down. Force in the same direction would speed you up, not slow you down. Perpendicular force would make you turn. Upward force fights gravity, not horizontal motion. Deceleration always requires force opposite to the direction of travel. Here's a WGU C165 OA exam tip for you. Slowing down means force opposite to motion. Speeding up means force in the same direction as motion. The word slow or brake signals opposing force. Quick recall hook. Slow means oppose. To slow something, push against its motion. 15. According to Newton's first law, an object at rest will remain at rest unless acted upon by an unbalanced force. You're pushing a shopping cart forward while your friend pushes backward with exactly equal force. What will happen to the cart in this situation? A. It will accelerate forward slowly. B. It will move backward gradually. C. It will remain at rest. D. It will oscillate back and forth. Do you know the answer? Correct answer, C. It will remain at rest. Explanation. Option C is correct because equal and opposite forces produce zero net force, meaning the forces are balanced, and the cart experiences no acceleration from rest. Option A is incorrect because forward acceleration would require an unbalanced net force in the forward direction, which does not exist when opposing forces are equal. Option B is incorrect because backward motion would require the backward force to exceed the forward force, but the forces are stated to be exactly equal. Option D is incorrect because oscillation would require changing unbalanced forces over time. With constant equal opposing forces, the cart simply remains stationary. Newton's first law. Objects at rest stay at rest unless an unbalanced force acts on them. You push a shopping cart forward. Your friend pushes backward with exactly equal force. What happens? Nothing. The cart stays put. Equal forces in opposite directions produce zero net force. No net force means no acceleration. An object at rest with balanced forces remains at rest. It won't slowly creep forward or backward because there's no unbalanced force to cause motion. It won't oscillate because the forces are constant, not changing. For motion to start, you'd need your force to exceed your friend's force, or vice versa, creating an unbalanced net force. Here's a WGU C165 OA exam tip for you. Equal and opposite forces mean zero net force and no acceleration. The phrase exactly equal force signals balanced forces and no motion change. Quick recall hook. Equal opposite means zero. Balanced forces produce no acceleration. 16. A heavy refrigerator sits on a kitchen floor, and you push against it, but it does not move despite your significant effort. Once you finally push hard enough and the refrigerator begins sliding, it becomes somewhat easier to keep it moving. What explains this change in the effort required? A. Gravity decreases when objects move. B. Static friction exceeds kinetic friction. C. Moving objects lose all their mass. D. The floor becomes more slippery. Do you know the answer? Correct answer. B. Static friction exceeds kinetic friction. Explanation. Option B is correct because static friction between stationary objects is typically greater than kinetic friction between moving objects, requiring more initial force to start motion. Option A is incorrect because gravitational force remains constant regardless of whether an object is moving or stationary. Gravity does not change based on motion state. Option C is incorrect because mass is an intrinsic property of matter that remains constant regardless of whether the object is moving or at rest on the floor. Option D is incorrect because the floor's surface properties do not physically change. The difference comes from the transition between static and kinetic friction forces. You push a heavy refrigerator. Nothing happens. Push harder. Still nothing. Finally, you push hard enough and it starts moving, and suddenly it's easier to keep moving than it was to start. Why? Two types of friction are at play. Static friction holds stationary objects in place. Kinetic friction acts on moving objects. Static friction is stronger than kinetic friction for the same surfaces. You need more force to break objects free from rest than to keep them sliding once they're moving. Gravity stays constant whether the fridge moves or not. The fridge doesn't lose mass. The floor doesn't magically become slippery. The physics changes because you've transitioned from overcoming static friction to working against kinetic friction. Here's a WGU C165 OA exam tip for you. When a question mentions easier to keep moving than to start, think static versus kinetic friction. Static is always greater than kinetic for the same surfaces. Quick recall hook. Starting is harder. Static friction exceeds kinetic friction. 17. When you walk across a room, you push backward against the ground with your foot. According to Newton's third law, the ground pushes forward on your foot, which propels you forward. What would happen if there were no friction between your shoes and the floor? A. You would walk faster easily. B. Gravity would pull you down. C. Your shoes would get warmer. D. You could not move forward. Can you guess the answer? Correct answer. D. You could not move forward. Explanation. Option D is correct because without friction, your foot would simply slide backward when you push, and the ground could not provide the forward reaction force needed for walking. Option A is incorrect because friction is essential for walking. Without it, you would slip and be unable to gain traction to move forward at any speed. Option B is incorrect because gravity acts vertically downward, regardless of friction. The question concerns horizontal motion, which requires friction for walking propulsion. Option C is incorrect because warmth from friction occurs when surfaces rub together during movement. Without friction, this heat generation would not occur. When you walk, your foot pushes backward against the ground. Newton's third law says the ground pushes back, forward on your foot, and that forward push propels you. But this only works because of friction. Friction is what allows your foot to grip the ground and push against it. Without friction, your foot would just slide backward when you try to push. The ground couldn't push you forward because there's nothing connecting your push to the ground's response. Think of walking on ice. You slip because there's almost no friction to let you push effectively against the surface. Friction is literally what makes walking possible. Gravity would still pull you down without friction, but that's vertical. It doesn't help horizontal movement. Here's a WGU C165 OA exam tip for you. Friction enables the ground's reaction force in walking. No friction means no forward propulsion. The phrase no friction in a walking scenario means no movement. Quick recall hook. Friction lets you walk. No grip means no go. 18. A skydiver jumps from an airplane and immediately expects to accelerate rapidly toward Earth due to gravity. However, they experience strong wind resistance and much less acceleration than anticipated. As they fall faster, the air resistance increases until it eventually equals their weight. What happens to their motion at this point? A. They begin accelerating upward. B. They continue accelerating faster. C. They fall at constant velocity. D. They stop falling completely. Can you guess the answer? Correct answer. C. They fall at constant velocity. Explanation. Option C is correct because when air resistance equals weight, the forces are balanced with zero net force, so the skydiver stops accelerating and falls at constant terminal velocity. Option A is incorrect because balanced forces result in no acceleration, not reverse acceleration. The skydiver continues falling, just without further speed increase. Option B is incorrect because acceleration requires unbalanced forces. When air resistance equals weight, forces are balanced and acceleration stops, not increases. Option D is incorrect because balanced forces do not stop motion. They stop acceleration, meaning the skydiver continues falling at whatever constant velocity was reached. A skydiver jumps from a plane. Gravity pulls them down so they accelerate toward Earth. But as they fall faster, air resistance increases. Air pushes back harder the faster you go through it. Eventually, air resistance grows until it exactly equals the skydiver's weight. Now you have two equal forces in opposite directions. Gravity down, air resistance up. Net force becomes zero. Zero net force means zero acceleration. But zero acceleration doesn't mean stopping. It means no more speeding up. The skydiver continues falling at whatever speed they reached, called terminal velocity. Constant speed, not increasing, not decreasing. They don't accelerate upward because balanced forces produce no acceleration in any direction. They don't stop because there's no force to halt their existing motion. Here's a WGU C165 OA exam tip for you. When air resistance equals weight, forces balance and velocity becomes constant. The phrase equals their weight signals terminal velocity. Quick recall hook. Equal forces, constant speed. Balanced forces mean no acceleration, not no motion. 19. Car brakes work by creating friction between brake pads and the spinning wheel components, which converts the car's kinetic energy into heat and slows the vehicle. Over time, brake pads wear down and must be replaced. Besides stopping vehicles, what other common activity depends entirely on friction to function? A. Floating in water. B. Striking a match. C. Hearing sounds. D. Seeing colours. What do you think is the answer? Correct answer, B. Striking a match. Explanation. Option B is correct because striking a match requires friction between the match head and striking surface to generate enough heat through kinetic friction to ignite the match. Option A is incorrect because floating in water depends on buoyancy forces related to density and displaced water volume, not on friction between surfaces in contact. Option C is incorrect because hearing depends on sound wave vibrations travelling through air and being detected by the ear, not on friction between solid surfaces. Option D is incorrect because seeing colours involves light waves entering the eye and being processed by the brain, which is unrelated to friction forces between objects. Car brakes use friction to convert kinetic energy into heat, slowing the vehicle. Friction is everywhere, it's not just brakes. Striking a match depends entirely on friction. When you drag a match head across the striking surface, friction generates heat. That heat reaches the ignition temperature of the chemicals on the match head, and the match lights. No friction, no heat, no flame. Floating in water is about buoyancy, density and displaced water, not friction between surfaces. Hearing involves sound waves vibrating through air and being detected by your ear, no surface friction involved. Seeing colours is about light waves and your visual system, also unrelated to friction. Here's a WGU C165 OA exam tip for you. Friction converts kinetic energy to heat. Any process requiring heat from rubbing surfaces depends on friction. The match question tests whether you recognise friction's heat-generating role. Quick recall hook. Rub for heat. Friction creates heat which lights matches. 20. When sanding a piece of wood, simply dragging sandpaper lightly across the surface removes very little material and requires minimal effort. However, pressing down firmly while moving the sandpaper back and forth removes much more material, but requires significantly more force. What factor primarily explains this difference? A. Sandpaper becomes sharper with pressure. B. Wood softens under applied pressure. C. Pressing harder increases friction force. D. Light contact eliminates all friction. Can you guess the answer? Correct answer, C. Pressing harder increases friction force. Explanation. Option C is correct because friction force between solid objects increases when the surfaces press harder against each other, creating more resistance and more effective sanding action. Option A is incorrect because the sandpaper's abrasive properties remain constant regardless of applied pressure. The difference comes from the friction force, not sandpaper sharpness. Option B is incorrect because wood does not significantly soften under the pressure applied during hand sanding. The material properties remain essentially unchanged during the process. Option D is incorrect because light contact still produces some friction. It simply produces less friction than firm contact, making the sanding less effective but not frictionless. When sanding wood, light pressure removes almost nothing. Press harder, and suddenly you're taking off real material. The difference is friction force. Friction between two surfaces increases when you press them together harder. More pressure means more friction. More friction means more resistance when you move the sandpaper, and more abrasive action on the wood. The sandpaper itself doesn't change. It doesn't get sharper when you push harder. The wood doesn't soften under hand sanding pressure. And light contact doesn't eliminate friction entirely. It just produces less of it. The relationship is direct. Push harder, get more friction. Here's a WGU C165 OA exam tip for you. Friction force increases with normal force, which is how hard surfaces press together. Phrases like pressing harder or more pressure signal increased friction. Quick recall hook. Push harder, more friction. Normal force and friction are directly related. 21. Earth exerts gravitational force on you, pulling you toward its centre, which is why you remain on the ground rather than floating away. According to Newton's third law, if Earth pulls on you with a certain force, what must also be true about the gravitational relationship between you and Earth? A. You pull on Earth with equal force. B. Earth's gravity affects only you. C. Your gravity cancels Earth's gravity. D. No reaction force exists for gravity. What do you think is the answer? Correct answer, A. You pull on Earth with equal force. Explanation: option A is correct because Newton's third law states every action has an equal and opposite reaction. So you pull Earth upward with the same force Earth pulls you downward. Option B is incorrect because gravity is mutual. Both objects in a gravitational interaction experience force, though the effects are more noticeable on the less massive object. Option C is incorrect because the forces act on different objects and thus cannot cancel each other. Your force on Earth and Earth's force on you are an action-reaction pair. Option D is incorrect because Newton's third law applies to all forces including gravity. Every gravitational pull has a corresponding reaction force in the opposite direction. Earth pulls you down with gravity. You feel it constantly. It's why you don't float away. But here's something that might surprise you. You pull Earth up too. Same force, opposite direction. Newton's third law says every action has an equal and opposite reaction. Earth exerts gravitational force on you. You exert gravitational force on Earth. Both forces are identical in magnitude, so why don't you notice Earth moving toward you? Mass difference. You and Earth experience the same force, but Earth is incomprehensibly more massive. The same force that accelerates you noticeably toward Earth barely budges the planet. The forces don't cancel each other because they act on different objects. One on you, one on Earth. They're an action-reaction pair, not opposing forces on the same object. Here's a WGU C165 OA exam tip for you. Newton's third law applies to all forces, including gravity. When you see according to Newton's third law in a gravity question, look for equal and opposite forces. Quick recall hook. You pull Earth too. Gravity is always mutual. 22. The Sun has a mass hundreds of millions of times greater than Earth, which means it exerts tremendous gravitational force. Yet when you drop a coffee cup, it falls toward Earth rather than toward the much more massive Sun. What factor primarily explains why Earth's gravity dominates in this situation? A. The Sun's gravity cannot reach Earth. B. Earth is much closer than the Sun. C. Coffee cups are immune to solar gravity. D. The atmosphere blocks solar gravity. What do you think is the answer? Correct answer, B. Earth is much closer than the Sun. Explanation. Option B is correct because gravitational force decreases dramatically with distance. Earth's proximity means its gravitational effect on nearby objects greatly exceeds the distant Sun's effect. Option A is incorrect because gravity has infinite range and the Sun's gravity definitely reaches Earth. In fact, it is what keeps Earth in orbit around the Sun. Option C is incorrect because all objects with mass experience gravitational attraction from all other masses. Coffee cups are affected by solar gravity, just much less than by Earth's. Option D is incorrect because gravity passes through all matter, including atmosphere. Gravitational force is not blocked or absorbed by gases or any other materials in its path. The Sun is massive, hundreds of millions of times more massive than Earth. It exerts enormous gravitational pull. Yet when you drop a coffee cup, it falls toward Earth, not toward the Sun. Why? Distance. Gravitational force depends on two things, mass and distance. The Sun wins on mass by a landslide, but it loses on distance, badly. The Sun is about 150 million kilometers away. Earth is right beneath your feet. Gravity weakens dramatically with distance. That inverse square relationship means doubling the distance cuts the force to 1/4. The sun's gravity absolutely reaches Earth. That's what keeps us in orbit. Coffee cups experience solar gravity too, but Earth's proximity means its gravitational effect on nearby objects completely dominates. The atmosphere doesn't block gravity either. Gravity passes through everything. Here's a WGU C165 OA exam tip for you. When comparing gravitational effects, distance often matters more than mass for nearby objects. The phrase closer or proximity signals distance as the key factor. Quick recall hook, close beats big, nearby gravity dominates over distant mass. 23. Newton's law of universal gravitation states that gravitational force is inversely proportional to the square of the distance between two objects. If the distance between two objects is doubled while their masses remain the same, how does the gravitational force between them change? A. It doubles in strength. B. It becomes half as strong. C. It becomes 1/4 as strong. D. It remains exactly the same. Can you guess the answer? Correct. Answer C. It becomes 1/4 as strong. Explanation. Option C is correct because the inverse square relationship means doubling the distance squares to 4, and the inverse of 4 is 1/4 of the original gravitational force. Option A is incorrect because gravitational force decreases with distance, not increases. Doubling distance significantly weakens rather than strengthens the gravitational attraction between objects. Option B is incorrect because the relationship is inverse square, not simply inverse. Halving would occur if gravity were inversely proportional to distance, not distance squared. Option D is incorrect because gravitational force definitely depends on distance, according to Newton's law. Changing distance necessarily changes the gravitational force between objects. Newton's law of universal gravitation includes an inverse square relationship with distance. What does that actually mean? If you double the distance between two objects, you don't just halve the gravitational force, you quarter it. The math works like this. Double the distance means the distance squared is 4. Inverse of 4 is 1/4. So gravitational force drops to 1/4 of what it was. Triple the distance? 9 times the distance squared. Force becomes 1/9. This is why distance matters so much for gravity. Small changes in distance create big changes in force. The force doesn't stay the same. That would ignore distance entirely. It doesn't just halve. That would be a simple inverse relationship, not inverse square. Here's a WGU C165 OA exam tip for you. Inverse square means you square the distance change, then take the inverse. Double distance equals 1/4 force. Triple distance equals 1/9 force. Quick recall hook, square then flip. Square the distance multiplier, then invert it. 24. The planets in our solar system are constantly being pulled toward the sun by gravity, yet they do not fall into the sun and instead continue orbiting around it year after year. What characteristic of the planets prevents them from being pulled directly into the sun by gravitational attraction? A. The planets repel solar gravity. B. The planets have sideways motion. C. The sun's gravity is too weak. D. Space contains friction stopping them. Can you guess the answer? Correct answer, B. The planets have sideways motion. Explanation. Option B is correct because planets move sideways fast enough that while gravity pulls them toward the sun, they continuously fall around it rather than directly into it. Option A is incorrect because planets cannot repel gravity. All objects with mass attract each other gravitationally, and planets are continuously attracted toward the sun by gravity. Option C is incorrect because the sun's gravity is enormously strong due to its massive size. It is specifically what keeps all the planets in their orbits around the sun. Option D is incorrect because outer space is essentially a vacuum with no friction. The lack of friction is actually why planets can maintain their orbits indefinitely without slowing down. Gravity constantly pulls planets toward the sun, so why don't they fall in? They're moving sideways. Picture throwing a ball. It falls toward Earth while also moving forward. Throw it faster, it goes farther before hitting ground. Throw it impossibly fast, and by the time it falls, the curved Earth has dropped away beneath it. It keeps falling but never lands. That's an orbit. Planets work the same way. The sun's gravity pulls them inward constantly, but they're moving sideways fast enough that they keep missing the sun. They fall around it rather than into it. Planets can't repel gravity. Nothing can. The sun's gravity is enormously strong, not weak, and space has essentially no friction, which is actually why orbits persist indefinitely. Nothing slows the planets down. Here's a WGU C165 OA exam tip for you. Orbits happen because of sideways motion combined with gravitational pull. The phrase "do not fall into" signals the orbit concept. Quick recall hook. Falling sideways, orbits are perpetual falling that keeps missing. 25. A galaxy is a massive system of stars, planets, and other celestial objects, all held together by gravitational attraction. Scientists theorize that galaxies formed because matter in the early universe was distributed slightly unevenly, rather than perfectly uniformly. Why would perfectly uniform matter distribution have prevented galaxy formation? A. Uniform matter has no mass. B. Gravity only affects uneven distributions. C. Equal pulls in all directions prevent clumping. D. Stars cannot form from uniform matter. Can you guess the answer? Correct answer, C. Equal pulls in all directions prevent clumping. Explanation. Option C is correct because with perfectly uniform distribution, every piece of matter would be pulled equally in all directions, resulting in no net movement toward any gathering point. Option A is incorrect because uniformly distributed matter still possesses mass. The issue is not absence of mass, but the balanced nature of gravitational pulls from all directions. Option B is incorrect because gravity affects all matter, regardless of distribution. The issue is that uniform distribution creates balanced forces that prevent preferential clumping in any direction. Option D is incorrect because the raw material for star formation exists in uniform matter. The problem is that without uneven distribution, gravitational clumping to form dense regions cannot begin. Galaxies formed because the early universe wasn't perfectly uniform. There were slight density differences. Some regions had a bit more matter than others. Those denser regions had stronger gravity. They attracted more matter from surrounding areas. Over billions of years, matter clumped together into stars, then star clusters, then galaxies. But what if matter had been distributed perfectly evenly? No galaxies. Here's why. With perfect uniformity, every bit of matter would be pulled equally in all directions. Gravity from the left equals gravity from the right. From above equals below. Every direction cancels out. No net force toward any particular point means no preferential clumping. The matter has mass, that's not the issue. Gravity works on all matter regardless of distribution. But balanced pulls from all sides mean nothing moves anywhere. Here's a WGU C165 OA exam tip for you. Uniform distribution means equal gravitational pulls in all directions, preventing clumping. The phrase perfectly uniform signals balanced forces with no net movement. Quick recall hook. Uniform means stuck. Equal pulls everywhere means nothing clumps. 26. A construction worker carries a heavy brick up a ladder to the roof of a building. Compared to when the brick was on the ground, how has the energy of the brick changed now that it is on the roof? A. Its kinetic energy has increased. B. Its thermal energy has decreased. C. Its gravitational potential energy increased. D. Its chemical potential energy increased. What do you think is the answer? Correct answer, C. Its gravitational potential energy increased. Explanation: option C is correct, because lifting an object higher above the ground increases its gravitational potential energy, which is stored energy due to position relative to Earth. Option A is incorrect because kinetic energy relates to motion. If the brick is stationary on the roof, its kinetic energy is zero, not increased. Option B is incorrect because carrying a brick up a ladder does not reduce its thermal energy. Temperature is unrelated to the height change described here. Option D is incorrect because chemical potential energy is stored in chemical bonds within substances. Changing the brick's position does not alter its chemical composition. A worker carries a brick up a ladder to a roof. What changed about the brick's energy? It gained gravitational potential energy. Potential energy is stored energy. Energy an object has because of its position or condition. Gravitational potential energy specifically comes from height. The higher you lift something, the more gravitational potential energy it stores. That energy came from the worker's effort climbing the ladder. If the brick falls, that stored potential energy converts to kinetic energy, energy of motion. But sitting still on the roof, the brick has zero kinetic energy. Kinetic energy requires movement. Thermal energy relates to temperature, not height. Chemical potential energy involves bonds within substances. Lifting a brick doesn't change its chemical makeup. Here's a WGU C165 OA exam tip for you. Lifting something higher increases gravitational potential energy. The keywords higher, above ground, or elevated signal gravitational PE. Quick recall hook. Higher means stored, elevation stores gravitational potential energy. 27. Two vehicles are travelling on a highway. A motorcycle travels at a certain speed, while a large truck travels at the same speed. If both vehicles suddenly need to stop, which vehicle would cause more damage if it struck a barrier, and what primarily explains this difference? A. The motorcycle due to higher speed. B. The truck due to greater mass. C. Both cause equal damage at same speed. D. The motorcycle due to less friction. Can you guess the answer? Correct answer, B. The truck due to greater mass. Explanation: option B is correct because kinetic energy depends on both mass and velocity. At equal speeds, the truck's greater mass gives it significantly more kinetic energy. Option A is incorrect because both vehicles are travelling at the same speed, according to the scenario, so speed does not differentiate their potential damage. Option C is incorrect because kinetic energy increases with mass. Therefore, equal speed does not result in equal kinetic energy when masses differ significantly. Option D is incorrect because friction affects stopping distance, but the question asks about impact damage, which relates to kinetic energy based on mass and velocity. A motorcycle and a truck travel at the same speed on a highway. Both need to stop suddenly. Which causes more damage hitting a barrier? The truck. Same speed but vastly different mass. Kinetic energy, the energy of motion, depends on both mass and velocity. The formula is 1/2 times mass times velocity squared. At equal speeds, the velocity term is identical for both vehicles. But the truck has enormously more mass. More mass at the same speed means more kinetic energy. More kinetic energy means more damage upon impact. The motorcycle doesn't cause more damage due to speed. They're going the same speed. Equal speed doesn't mean equal damage when masses differ. Friction affects stopping distance, not impact energy. Here's a WGU C165 OA exam tip for you. At equal speeds, greater mass means greater kinetic energy. The phrase same speed with different objects points to mass as the determining factor. Quick recall hook. Same speed, mass wins. Heavier objects carry more kinetic energy. 28. When you charge your cell phone, electrical energy from the outlet is transferred into the phone's battery and stored for later use. What form of energy is being stored in the phone's battery during the charging process? A. Thermal energy. B. Electromagnetic energy. C. Gravitational potential energy. D. Chemical potential energy. What do you think is the answer? Correct answer, D. Chemical potential energy. Explanation. Option D is correct because batteries store energy in chemical bonds. Charging causes chemical reactions that store energy, which can later be released as electrical energy. Option A is incorrect because while some heat is generated during charging, the primary purpose is storing energy in chemical bonds, not as thermal energy. Option B is incorrect because electromagnetic energy refers to light and radiation. Batteries do not store energy as electromagnetic waves within their structure. Option C is incorrect because gravitational potential energy requires height above ground. A battery's energy storage is unrelated to its position or elevation. When you plug in your phone to charge, electrical energy flows from the outlet into the battery. But what form does that energy take once it's stored? Chemical potential energy. Batteries don't store electricity directly. They store energy in chemical bonds. Charging causes chemical reactions inside the battery that rearrange atoms and molecules into higher energy configurations. When you use the phone, those reactions reverse, releasing that stored chemical energy back as electrical energy. The battery might warm up during charging. That's thermal energy. But heat isn't the goal. The goal is storing energy in chemical bonds. Electromagnetic energy is light and radiation. Gravitational potential energy requires height changes. Neither applies to a battery sitting on your desk. Here's a WGU C165 OA exam tip for you. Batteries store chemical potential energy in their bonds. Any question about energy stored in a battery points to chemical PE. Quick recall hook. Batteries are chemical. Charging rearranges bonds to store energy. 29. All substances are made up of tiny particles called atoms and molecules that are constantly in motion. The energy produced by the random motion of these particles within a substance is called what type of energy? A. Thermal energy. B. Electromagnetic energy. C. Elastic potential energy. D. Chemical potential energy. Do you know the answer? Correct answer, A. Thermal energy. Explanation. Option A is correct because thermal energy results from the kinetic energy of moving atoms and molecules within a substance, which determines its temperature. Option B is incorrect because electromagnetic energy is carried by electromagnetic waves, such as light and radio waves, not by the motion of particles within matter. Option C is incorrect because elastic potential energy is stored in stretched or compressed objects, like springs and rubber bands, not in particle motion. Option D is incorrect because chemical potential energy is stored within the bonds between atoms in molecules, not in the random motion of particles. Everything around you is made of atoms and molecules in constant motion. Even in solid objects, particles vibrate. In liquids, they slide past each other. In gases, they zoom around freely. This random particle motion is thermal energy. Temperature measures how fast particles are moving on average. Hotter objects have faster moving particles. Colder objects have slower particles. Absolute zero, the coldest possible temperature, is when particle motion stops entirely. Thermal energy isn't electromagnetic energy, which involves light waves travelling through space. It's not elastic potential energy, which is stored in stretched or compressed materials. And it's not chemical potential energy, which sits in the bonds between atoms. Thermal energy is specifically about particle motion within matter. Here's a WGU C165 OA exam tip for you. Random particle motion equals thermal energy. The phrases particle movement, molecular motion, or temperature all point to thermal energy. Quick recall hook. Moving particles mean heat. Thermal energy is motion at the atomic level. 30. A climber is preparing to scale a mountain and packs energy bars for the journey. The climber's body will convert the energy stored in these snacks into the energy needed for climbing. What energy conversion primarily occurs when the climber eats and then climbs? A. Thermal to electromagnetic energy. B. Chemical potential to kinetic energy. C. kinetic to gravitational potential energy. D. Elastic potential to thermal energy. Can you guess the answer? Correct answer, B. Chemical potential to kinetic energy. Explanation: option B is correct because food contains chemical potential energy in its bonds, which the body converts to kinetic energy for movement during climbing activities. Option A is incorrect because eating and climbing do not involve converting thermal energy into electromagnetic energy. These energy types are unrelated to food consumption. Option C is incorrect because while the climber gains gravitational potential energy when ascending, the source energy is chemical potential, not kinetic energy being converted. Option D is incorrect because elastic potential energy involves stretch materials like springs. Food energy is chemical potential, not elastic in nature. A climber eats an energy bar before scaling a mountain. The food provides fuel for the climb. What's actually happening energetically? Chemical potential energy converts to kinetic energy. Food stores energy in chemical bonds, the bonds between atoms in carbohydrates, fats, and proteins. Your body breaks those bonds through metabolism, releasing that stored energy. That released energy powers muscle contractions, which create movement, kinetic energy. The climber also gains gravitational potential energy by going up, but that's the destination of energy, not the source. The source is chemical potential energy from food. This isn't thermal to electromagnetic conversion. Eating doesn't involve light. It's not elastic potential energy. No springs involved in food. Here's a WGU C165 OA exam tip for you. Eating food and moving means chemical PE converts to kinetic energy. Food questions almost always involve chemical potential energy as the source. Quick recall hook: food fuels motion. Chemical bonds in food become kinetic energy of movement. 31. All electromagnetic waves travel at the same speed in a vacuum, known as the speed of light. Given this fact, what happens to the frequency of an electromagnetic wave as its wavelength increases? A. Frequency decreases inversely. B. Frequency increases proportionally. C. Frequency remains unchanged. D. Frequency fluctuates randomly. Do you know the answer? Correct answer, A. Frequency decreases inversely. Explanation: option A is correct because wavelength and frequency have an inverse relationship. When wavelength increases, fewer wave crests pass a point per second, meaning lower frequency. Option B is incorrect because wavelength and frequency are inversely related, not directly proportional. As one increases, the other must decrease at constant speed. Option C is incorrect because frequency must change when wavelength changes if wave speed remains constant. The two properties are mathematically linked together. Option D is incorrect because the relationship between wavelength and frequency is predictable and consistent, not random. It follows precise physical laws for electromagnetic waves. All electromagnetic waves, light, radio, X-rays, everything, travel at the same speed in a vacuum, the speed of light. That speed is constant. So what happens when wavelength changes? Frequency must change inversely. Here's the relationship. Speed equals wavelength times frequency. If speed is locked in place and wavelength gets longer, frequency has to get lower to keep the equation balanced. Think of it like this. Wavelength is the distance between wave peaks. Frequency is how many peaks pass a point per second. Longer wavelengths mean fewer peaks fit in the same distance, so fewer pass by per second. Lower frequency. The two are inversely related. When one goes up, the other goes down. Here's a WGU C165 OA exam tip for you. Wavelength and frequency are inversely related for electromagnetic waves. Longer wavelength means lower frequency. The formula to remember is speed equals wavelength times frequency. Quick recall hook. Long waves, slow cycles. Longer wavelength means lower frequency. 32. The electromagnetic spectrum includes many different types of radiation, arranged by their wavelengths. Which type of electromagnetic radiation has the longest wavelengths, lowest frequencies, and lowest energy levels of all electromagnetic waves? A. Gamma rays. B. X-rays. C. Ultraviolet radiation. D. Radio waves. Can you guess the answer? Correct answer, D. Radio waves. Explanation: option D is correct because radio waves have wavelengths ranging from meters to millions of meters, making them the longest wavelength and lowest energy electromagnetic radiation. Option A is incorrect because gamma rays have the shortest wavelengths and highest frequencies, giving them the highest energy of all electromagnetic radiation types. Option B is incorrect because X-rays have shorter wavelengths than visible light and much shorter than radio waves, placing them in the high-energy portion of the spectrum. Option C is incorrect because ultraviolet radiation has shorter wavelengths than visible light, placing it between visible light and X-rays on the electromagnetic spectrum. The electromagnetic spectrum arranges all types of radiation by wavelength. At one extreme, gamma rays have incredibly short wavelengths, shorter than atoms. At the other extreme, radio waves stretch for meters, even kilometers. Which has the longest wavelength, lowest frequency, and lowest energy? Radio waves. The relationship is straightforward. Longer wavelength means lower frequency, means lower energy. Radio waves are at the far end of the spectrum. Longest, slowest, weakest. Gamma rays are the opposite extreme. Shortest wavelength, highest frequency, highest energy. X-rays and ultraviolet are also high energy, short wavelength radiation, just not quite as extreme as gamma rays. Here's a WGU C165 OA exam tip for you. Radio waves have the longest wavelength and lowest energy. Gamma rays have the shortest wavelength and highest energy. Picture the spectrum from radio to gamma as going from long and weak to short and strong. Quick recall hook. Radio is relaxed, longest wavelength, lowest energy, most chill. 33. When sunlight passes through a glass prism, it separates into a rainbow of colours that humans can see. Within the visible light portion of the electromagnetic spectrum, which colour has the longest wavelength and the lowest energy? A. Red. B. Violet. C. Blue. D. Green. Do you know the answer? Correct answer, A. Red. Explanation: option A is correct because red light has the longest wavelength within visible light, and since energy is inversely related to wavelength, red has the lowest energy. Option B is incorrect because violet light has the shortest wavelength in the visible spectrum, which means it has the highest energy, not the lowest energy. Option C is incorrect because blue light has a shorter wavelength than red, and therefore higher energy. It falls between violet and green on the spectrum. Option D is incorrect because green light falls in the middle of the visible spectrum, with medium wavelength and energy, not the longest wavelength or lowest energy. When sunlight passes through a prism, it splits into a rainbow, the visible spectrum: red, orange, yellow, green, blue, violet. Within this visible range, which colour has the longest wavelength and lowest energy? Red. The visible spectrum is just a tiny slice of the electromagnetic spectrum, but it follows the same rules. Longer wavelength means lower energy. Red light has the longest wavelength of visible colours, so it carries the least energy. Violet is the opposite: shortest visible wavelength, highest visible energy. Blue is close to violet, also high energy. Green sits in the middle. Remember Roy G. Biv: red, orange, yellow, green, blue, indigo, violet. Goes from longest to shortest wavelength, lowest to highest energy. Here's a WGU C165 OA exam tip for you. Red has the longest wavelength and lowest energy in visible light. Violet has the shortest wavelength and highest energy. Roy G. Biv goes from weak to strong. Quick recall hook. Red is restful. Longest wavelength, lowest energy in visible light. 34. A hospital uses different types of electromagnetic radiation for various medical purposes. One type can penetrate deep into the body to image bones, while another type with even higher energy is used to destroy cancer cells. What relationship explains why higher frequency radiation can penetrate and affect tissue more than lower frequency radiation? A. Lower frequency waves are faster. B. Higher frequency means higher energy. C. All frequencies have equal penetration. D. Wavelength is unrelated to energy. What do you think is the answer? Correct answer, B. Higher frequency means higher energy. Explanation. Option B is correct because electromagnetic wave energy increases with frequency. Higher energy waves like X-rays and gamma rays can penetrate materials and affect cells more significantly. Option A is incorrect because all electromagnetic waves travel at the same speed in a vacuum. Frequency does not affect the speed of electromagnetic radiation. Option C is incorrect because different frequencies have vastly different penetration abilities. Gamma rays penetrate most materials, while radio waves cannot penetrate solid objects. Option D is incorrect because wavelength, frequency, and energy are all mathematically related. Shorter wavelength means higher frequency, and therefore higher energy levels. Hospitals use different types of electromagnetic radiation for different purposes. X-rays penetrate tissue to image bones. Gamma rays, even higher energy, destroy cancer cells in radiation therapy. Why can high-frequency radiation penetrate and affect tissue more than low-frequency radiation? Energy. Higher frequency means higher energy. Higher energy waves carry more punch. They can push through materials, break molecular bonds, and affect cells in ways low-energy waves cannot. All electromagnetic waves travel at the same speed. Frequency doesn't make them faster, but frequency directly determines energy. Short wavelength, high frequency, high energy, these always go together. That's why gamma rays are dangerous and radio waves pass through you harmlessly. Here's a WGU C165 OA exam tip for you. Higher frequency equals higher energy equals greater penetration and biological effect. Medical imaging and radiation therapy questions tie directly to this frequency-energy relationship. Quick recall hook. High frequency hits. Hard, more frequency means more energy, means more effect. 35. A homeowner uses a remote control to operate their television and a cell phone to browse the internet. Both devices rely on electromagnetic radiation to transmit information wirelessly. Which portions of the electromagnetic spectrum do these two common technologies primarily use? A. Gamma rays and X-rays. B. Ultraviolet and visible light. C. Radio waves and gamma rays. D. Infrared and microwaves. Can you guess the answer? Correct answer. D. Infrared and microwaves. Explanation. Option D is correct because most remote controls use infrared radiation to communicate with devices, while cell phones primarily use microwave frequencies for wireless communication. Option A is incorrect because gamma rays and X-rays are high-energy radiation used in medical applications, not in consumer electronics for wireless communication purposes. Option B is incorrect because while some technologies use visible light, standard remote controls use infrared, and cell phones use microwaves, not ultraviolet radiation. Option C is incorrect because while radio waves are used in some communications, gamma rays are far too energetic and dangerous for consumer electronic applications. Your TV remote and your cell phone both use electromagnetic radiation to communicate wirelessly, but which parts of the spectrum? The remote uses infrared, invisible light just beyond red in wavelength. Point it at the TV, press a button. Infrared signal travels to the sensor. Cell phones use microwaves, longer wavelength than infrared, shorter than radio waves. Microwaves carry your voice and data to cell towers. Neither device uses gamma rays or X-rays. Those are medical and industrial applications, way too energetic for consumer electronics. Ultraviolet isn't used for these communications either. The answer pairs infrared with microwaves, two neighbouring regions of the spectrum commonly used in everyday wireless technology. Here's a WGU C165 OA exam tip for you. Remote controls use infrared, cell phones use microwaves. Both are low energy, safe portions of the spectrum for everyday wireless communication. Quick recall hook, remote infrared, phone microwave, common devices, specific spectrum regions. 36. Ice cubes maintain their shape when removed from the freezer and placed on a plate, at least until they begin to melt. This characteristic of keeping a fixed shape is a defining property of which state of matter, and what causes this behaviour at the particle level. A. Gas with fast-moving particles. B. Solid with vibrating particles. C. Liquid with sliding particles. D. Plasma with ionized particles. Can you guess the answer? Correct answer, B. Solid with vibrating particles. Explanation: option B is correct because in solids, particles have low energy and vibrate in fixed positions rather than moving freely, which maintains the solid's definite shape. Option A is incorrect because gas particles have high energy and move rapidly in all directions, causing gases to have no fixed shape and to fill their containers. Option C is incorrect because liquid particles can slide past each other, allowing liquids to flow and take the shape of their container rather than maintaining fixed shape. Option D is incorrect because plasma is an ionized gas state, not relevant to ice. The question describes solid behaviour, not the fourth state of matter. Ice cubes hold their shape when you take them out of the freezer, at least until they melt. This fixed shape property defines solids. At the particle level, solid particles have low energy. They don't have enough energy to break free from their neighbours. Instead, they vibrate in fixed positions, jiggling back and forth but staying in place. That locked arrangement maintains the solid's shape. Gases are the opposite. Particles have high energy, move rapidly in all directions, no fixed shape at all. Liquids fall in between. Particles slide past each other, taking container shape but not flying apart. Plasma is ionized gas, not relevant to ice behaviour. Here's a WGU C165 OA exam tip for you. Fixed shape means solid, particles vibrating in fixed positions. Look for phrases like maintained shape or definite shape, pointing to solid state. Quick recall hook, fixed shape, fixed position. Solids hold shape because particles vibrate in place. 37. When you pour water from a pitcher into a glass, the water takes the shape of the glass rather than maintaining the shape it had in the pitcher. However, the amount of water stays the same regardless of the container shape. What properties does this demonstrate about liquids? A. Fixed shape and fixed volume. B. No fixed shape and no fixed volume. C. No fixed shape but fixed volume. D. Fixed shape but no fixed volume. Do you know the answer? Correct answer, C. No fixed shape but fixed volume. Explanation: option C is correct because liquids take the shape of their container, demonstrating no fixed shape, but maintain constant volume because particles remain close together. Option A is incorrect because liquids do not have fixed shape. They flow and conform to whatever container holds them, unlike solids which maintain their shape. Option B is incorrect because while liquids lack fixed shape, they do have fixed volume. You cannot significantly compress a liquid into a smaller space. Option D is incorrect because this describes the opposite of liquid properties. Liquids change shape readily but maintain their volume when transferred between containers. Pour water from a pitcher into a glass. The water changes shape. It was pitcher-shaped, now it's glass-shaped. but the amount stays the same. You have exactly as much water as before. This demonstrates liquid properties. No fixed shape, but fixed volume. Liquids flow. They conform to whatever container holds them. But you can't compress them significantly. Particles are close enough together that there's no room to squeeze. Solids have both fixed shape and fixed volume. They don't flow or compress. Gases have neither. They expand to fill any container and compress easily. Liquids sit in between, flexible in shape but stubborn about volume. Here's a WGU C165 OA exam tip for you. Liquids have no fixed shape but fixed volume. The phrase takes shape of container signals liquid state. If volume also changes, that's a gas. Quick recall hook. Liquid flows but fills, no fixed shape, yes fixed volume. 38. When you pump air into a bicycle tyre, you can feel the tyre becoming firmer as more air is added to the same space. This occurs because gas particles are being compressed into a smaller volume per particle. What microscopic property of gases allows them to be compressed unlike liquids and solids? A. Gas particles move very slowly. B. Gas particles are tightly packed together. C. Gas particles have strong attractive forces. D. Gas particles are spread far apart. Do you know the answer? Correct answer. D. Gas particles are spread far apart. Explanation. Option D is correct because gas particles have high energy and spread far apart, leaving empty space between them that allows compression when pressure is applied. Option A is incorrect because gas particles actually move very quickly due to their high energy. Slow movement is characteristic of solid particles vibrating in place. Option B is incorrect because tightly packed particles are characteristic of solids and liquids, which cannot be significantly compressed due to particles being close together. Option C is incorrect because gas particles have overcome attractive forces due to their high energy. Weak attractions between particles allow them to spread apart freely. Pump air into a bicycle tyre. The tyre gets firmer as you add more air to the same space. You're compressing gas, squeezing more particles into a fixed volume. Gases allow this because of how their particles are arranged, spread far apart, with lots of empty space between them. When you apply pressure, you push particles closer together, filling that empty space. Liquids and solids can't be compressed much because their particles are already close together. No empty space to eliminate. Gas particles aren't slow, they're actually moving very fast in random directions. They aren't tightly packed. That would be a solid. They haven't overcome attractive forces by having strong ones. They've overcome them by having enough energy that weak attractions can't hold them together. Here's a WGU C165 OA exam tip for you. Gases compress because particles are spread far apart with empty space between them. The phrase can be compressed signals gas state and widely spaced particles. Quick recall hook. Spread apart, squeeze together. Gas compresses because particles aren't touching. 39. Dry ice is solid carbon dioxide that transforms directly into carbon dioxide gas at room temperature without first becoming a liquid. When metal is heated in a foundry until it flows, it transforms from solid to liquid form. What do these two examples demonstrate about matter? A. All substances melt at room temperature. B. Different substances change states differently. C. Gases always become liquids first. D. Solids cannot transform into gases. What do you think is the answer? Correct answer. B. Different substances change states differently. Explanation. Option B is correct because dry ice sublimates directly to gas, while metals must first melt to liquid, showing that substances have different phase change behaviours and temperatures. And Option A is incorrect because most substances do not melt at room temperature. Metals require extremely high temperatures to become liquid, far above normal room conditions. Option C is incorrect because the dry ice example specifically shows that some solids transform directly into gas, skipping the liquid phase entirely through sublimation. Option D is incorrect because dry ice demonstrates that solids can become gases. This process is called sublimation and occurs with certain substances under specific conditions. Dry ice sits on a table and seems to disappear. It goes directly from solid to gas without becoming liquid first. That's sublimation. Meanwhile, in a foundry, workers heat metal until it flows like water, solid to liquid, the normal melting process. Same basic idea, changing states, but completely different pathways. Different substances behave differently during phase changes. Dry ice sublimates at room temperature because carbon dioxide's properties favour direct solid-to-gas transition under normal atmospheric pressure. Metals require extreme heat to melt and don't sublimate under normal conditions. Not all substances melt at room temperature. Most don't. Solids absolutely can become gases directly. Dry ice proves it. The key insight is that each substance has its own phase change behaviour. Here's a WGU C165 OA exam tip for you. Different substances have different phase change temperatures and pathways. Sublimation means solid directly to gas. The phrase without becoming liquid signals sublimation. Quick recall hook. Substances are individuals. Each has unique phase change behaviour. 40. A pot of water is heated on a stove until it boils and produces steam. As water molecules transform from liquid to gas, their behaviour changes dramatically. What happens to the energy and movement of water particles during this transformation from liquid to gaseous state? A. Particles gain energy and move faster. B. Particles lose energy and slow down. C. Particles maintain the same energy level. D. Particles lose energy and speed up. What do you think is the answer? Correct answer, A. Particles gain energy and move faster. Explanation. Option A is correct because phase change from liquid to gas requires adding energy, which increases particle movement, enough to overcome attractive forces and spread apart. Option B is incorrect because losing energy would cause particles to slow down and potentially change to solid state, not transform from liquid to faster moving gas. Option C is incorrect because a phase change from liquid to gas requires significant energy input. The particles cannot remain at the same energy level during boiling. Option D is incorrect because particles cannot simultaneously lose energy and speed up. Energy and speed are directly related, with more energy meaning faster particle motion. Heat a pot of water on the stove. Eventually it boils, producing steam. Liquid water becomes gaseous water vapour. What happens to the particles during this transformation? They gain energy and move faster. In liquid water, particles have enough energy to slide past each other but not enough to escape entirely. Add heat energy and particles move faster and faster. At the boiling point, they have enough energy to break free from neighbouring particles completely. They spread apart, moving rapidly in all directions as a gas. Losing energy would slow particles down. That's cooling, not boiling. Particles don't maintain the same energy during phase change. The whole point is adding enough energy to change state. Energy and speed are directly linked. More energy always means faster motion. Here's a WGU C165 OA exam tip for you. Liquid to gas requires adding energy, which increases particle speed. The phrase phase change from liquid to gas always involves energy gain. Quick recall hook. Boiling means boosting. Adding energy speeds particles into gas phase. 41. When ice melts into liquid water and then evaporates into water vapour, the appearance changes dramatically at each stage. However, throughout these transformations, the chemical composition remains the same water molecules. What type of change do these transformations represent? A. Chemical change with new substances. B. Nuclear change with atomic alteration. C. Combustion change with energy release. D. Physical change without new substances. Can you guess the answer? Correct answer. D. Physical change without new substances. Explanation. Option D is correct because phase changes alter appearance and form without changing chemical composition. Water remains water molecules regardless of being ice, liquid or vapor. Option A is incorrect because chemical changes produce new substances with different compositions. Water molecules remain chemically identical throughout all phase changes. Option B is incorrect because nuclear changes involve alterations to atomic nuclei. Phase changes do not affect the atoms themselves, only how molecules are arranged. Option C is incorrect because combustion involves chemical reactions that produce new substances. Melting and evaporating water do not involve combustion reactions. Ice melts into water. Water evaporates into steam. Dramatic visual changes at each step, solid to liquid to gas. But here's the thing, it's still water. H2O the whole way through. The molecules don't change. No new substances form. This is a physical change. Physical changes alter appearance, form or state, without changing what the substance actually is. Chemical changes create entirely new substances with different compositions. Nuclear changes mess with atomic nuclei. That's radioactivity territory. Combustion is a specific chemical reaction involving burning and oxygen. None of those apply here. Ice, liquid water and steam are all the same chemical substance in different physical states. The molecules just move differently and arrange themselves differently. Here's a WGU C165 OA exam tip for you. Phase changes are always physical changes. If the chemical formula stays the same, it's physical. The phrase same composition or same molecules signals physical change. Quick recall hook. Same stuff, different look. Physical changes alter appearance, not identity. 42. When you light a candle, the solid wax near the wick first melts and is absorbed into the wick. Then as the melted wax reaches the flame, it combines with oxygen from the air to produce carbon dioxide and water vapour. Which part of this process represents a chemical change rather than a physical change? A. The wax melting near the wick. B. The wax combining with oxygen. C. The melted wax being absorbed. D. The flame producing light. What do you think is the answer? Correct answer. B. The wax combining with oxygen. Explanation. Option B is correct because combining wax with oxygen creates entirely new substances through chemical bonds being broken and reformed, defining a chemical change. Option A is incorrect because melting is a physical change, where wax molecules remain chemically identical but simply change from solid to liquid state without new substances. Option C is incorrect because absorption into the wick is a physical process involving movement of liquid wax. No new chemical substances are created during this step. Option D is incorrect because while the flame produces light, the chemical change specifically occurs when wax molecules react with oxygen to form different compounds. A candle burning involves multiple processes happening at once. The solid wax near the wick melts. That's physical, just a state change from solid to liquid. The liquid wax gets absorbed into the wick fibres. Also physical, just movement of liquid through material. But then comes the interesting part. The wax vapour at the flame combines with oxygen from the air. Wax plus oxygen produces carbon dioxide and water vapour. Different substances come out than went in. Bonds break, new bonds form, entirely new molecules result. That's a chemical change. The flame-producing light is a result of the chemical reaction, but the actual chemical change is the wax combining with oxygen. Melting and absorption don't create new substances. They're physical processes. Here's a WGU C165 OA exam tip for you. Combustion is always a chemical change because it creates new substances. The phrase combines with oxygen signals a chemical reaction. Quick recall hook. New stuff means chemical. When different substances form, it's chemical change. 43. In a chemical reaction, the starting materials are combined and transformed into different materials through the breaking and forming of chemical bonds. What are the substances present before a chemical reaction begins called? And what are the new substances formed called? A. Products and reactants respectively. B. Compounds and elements respectively. C. Molecules and atoms respectively. D. Reactants and products respectively. What do you think is the answer? Correct answer. D. Reactants and products respectively. Explanation. Option D is correct because reactants are substances present before the reaction that get transformed, while products are the new substances created by the chemical reaction. Option A is incorrect because this reverses the correct terminology. Products are the end results, not the starting materials, and reactants are the starting materials. Option B is incorrect because compounds and elements describe types of matter, not their role in chemical reactions. Both can serve as reactants or products. Option C is incorrect because molecules and atoms describe particle types, not positions in reactions. Reactions involve rearranging atoms and molecules into new arrangements. Chemical reactions transform starting materials into different materials. Simple concept, but the terminology trips people up. The starting materials, what you begin with before the reaction, are called reactants. They react. The new materials formed by the reaction, what you end up with, are called products. They're produced. Reactants go in, products come out. Don't reverse them. Products and reactants aren't the same as compounds and elements. Those describe what type of matter something is, not its role in a reaction. An element can be a reactant. A compound can be a product. Same with molecules and atoms. They describe particle types, not positions in the reaction sequence. Here's a WGU C165 OA exam tip for you. Reactants are starting materials, products are ending materials. The reaction arrow points from reactants to products. Think of it like a factory. Raw materials go in, finished products come out. Quick recall hook. React first, produce last. Reactants start it, products finish it. 44. When sugar dissolves completely in water, it seems to disappear because you can no longer see it. However, if you taste the water, it is sweet, proving the sugar is still present. What fundamental law explains why the sugar cannot simply vanish during this process? A. Law of conservation of mass. B. Law of conservation of energy. C. Law of conservation of momentum. D. Law of universal gravitation. What do you think is the answer? Correct answer. A. Law of conservation of mass. Explanation. Option A is correct because conservation of mass states matter cannot be created or destroyed. Dissolved sugar molecules still exist even though they are no longer visible. Option B is incorrect because conservation of energy relates to energy transformations, not to whether matter like sugar continues to exist after dissolving in water. Option C is incorrect because conservation of momentum relates to motion in collisions. It does not explain why matter persists when dissolved or chemically changed. Option D is incorrect because universal gravitation describes attractive forces between masses. It does not address whether matter is conserved during physical or chemical processes. Dissolve sugar in water. It disappears, you can't see it anymore, but taste the water. Sweet. The sugar didn't vanish into nothing. It's still there, just dispersed among water molecules at a scale too small to see. This demonstrates the law of conservation of mass. Matter cannot be created or destroyed. The sugar molecules still exist. They didn't pop out of existence just because they became invisible. If you evaporated all the water, you'd get your sugar back. Conservation of energy is about energy transformations, not matter persistence. Conservation of momentum deals with motion in collisions. Universal gravitation describes attractive forces between masses. Only conservation of mass explains why matter persists through physical and chemical changes. Here's a WGU C165 OA exam tip for you. When something seems to disappear but is actually still present, that's conservation of mass. The phrase cannot simply vanish, or still exists, points directly to this law. Quick recall hook. Matter can't vanish. Conservation of mass means stuff doesn't disappear. 45. A car's engine converts gasoline into motion by combining the fuel with oxygen from the air in a combustion reaction. The products of this reaction are carbon dioxide and water vapour, which exit through the exhaust. Even though the gasoline seems to disappear, what must be true about the total mass of reactants compared to the total mass of products? A. Products have greater mass than reactants. B. Mass of reactants equals mass of products. C. Reactants have greater mass than products. D. Mass comparison is impossible to determine. Do you know the answer? Correct answer: B. Mass of reactants equals mass of products. Explanation: Option B is correct because conservation of mass requires that total mass before and after any chemical reaction remains equal, even when products become invisible gases. Option A is incorrect because matter cannot be created. Products cannot have more mass than the reactants that form them, according to conservation principles. Option C is incorrect because matter cannot be destroyed. Even though gasoline seems to vanish, its mass is converted to product masses, not lost entirely. Option D is incorrect because mass can definitely be measured before and after reactions. Conservation of mass is a proven scientific law applicable to all chemical reactions. Gasoline burns in your car engine, fuel combines with oxygen, combustion happens, and out the exhaust comes carbon dioxide and water vapour. The gasoline seems to vanish. You started with a tank of liquid and ended with invisible gases. But here's the key: if you could capture and weigh everything, the total mass of reactants would exactly equal the total mass of products. Gasoline plus oxygen equals carbon dioxide plus water vapour. Mass in equals mass out. This is conservation of mass applied to chemical reactions. Matter isn't created. Products can't weigh more than what went in. Matter isn't destroyed. Even though gasoline seems to disappear, its mass shows up in the product gases. You absolutely can measure mass before and after reactions. Scientists do it constantly. Here's a WGU C165 OA exam tip for you. In any chemical reaction, total mass of reactants equals total mass of products. The phrase seems to disappear in combustion questions always leads to conservation of mass. Quick recall hook. Mass in equals mass out. Combustion conserves mass, it just changes form. 46. What is a primary disadvantage of relying on solar energy as a power source? A. It produces harmful greenhouse gases. B. It requires fossil fuel combustion. C. It depends on weather and location. D. It depletes a finite natural resource. What do you think is the answer? Correct answer: C. It depends on weather and location. Explanation: Option C is correct because solar energy production varies with cloud cover, seasons, and geographic location, making it intermittent and requiring backup power sources or storage. Option A is incorrect because solar panels produce electricity without direct greenhouse gas emissions during operation, unlike fossil fuel power plants that emit carbon dioxide. Option B is incorrect because solar panels convert sunlight directly to electricity through photovoltaic cells without any combustion process or burning of fuels. Option D is incorrect because sunlight is considered an infinite renewable resource. The sun will continue producing energy for billions of years without depletion. Solar panels convert sunlight directly to electricity. No burning, no moving parts, no emissions during operation. Sounds perfect. But there's a catch. The sun doesn't always shine. Clouds block it. Night eliminates it. Winter reduces it. Geographic location matters. Polar regions get far less sunlight than equatorial ones. This intermittency is solar's primary disadvantage. You can't control when the sun shines, so you can't control when you generate power. Solar doesn't produce greenhouse gases during operation. That's an advantage, not a disadvantage. It doesn't require fossil fuel combustion. That's also an advantage. And sunlight isn't finite. The sun will keep shining for billions of years. The limitation is reliability, not cleanliness or sustainability. Here's a WGU C165 OA exam tip for you. Solar's main disadvantage is weather and location dependence. The phrases intermittent, variable, or depends on conditions all point to this limitation. Quick recall hook. Sun's not always there. Solar depends on weather and location. 47. Iceland generates a significant portion of its electricity and home heating from geothermal energy, using heat from underground volcanic activity. However, most countries cannot replicate Iceland's success with geothermal power. What primary factor limits the widespread adoption of geothermal energy worldwide? A. Geothermal requires tectonically active regions. B. Geothermal produces too much pollution. C. Geothermal technology does not exist yet. D. Geothermal is more expensive than fossil fuels. What do you think is the answer? Correct answer, A. Geothermal requires tectonically active regions. Explanation. Option A is correct because geothermal energy depends on underground heat from volcanic activity, which only exists near tectonic plate boundaries and geologically active areas. Option B is incorrect because geothermal energy is one of the cleanest energy sources with minimal emissions, producing far less pollution than fossil fuel combustion. Option C is incorrect because geothermal technology is well established and successfully operating in countries like Iceland, the United States, and the Philippines for decades. Option D is incorrect because while initial costs can be high, geothermal operating costs are low, so the main limitation is geographic availability, not overall economics. Iceland runs on geothermal energy, heat from underground volcanic activity. They tap into it for electricity and home heating. Brilliant solution, but most countries can't copy it. Why? Geography. Geothermal energy requires accessible underground heat. That heat exists near tectonic plate boundaries where volcanic activity concentrates. Iceland sits on the mid-Atlantic ridge, perfect location. Most places don't have that geology. Kansas can't drill into volcanic heat because there isn't any beneath Kansas. Geothermal is actually very clean, minimal pollution, one of the greenest energy sources. The technology exists and works well. Iceland proves it. Cost isn't the main barrier either. The fundamental limitation is that you need to be in the right place geologically. Here's a WGU C165 OA exam tip for you. Geothermal requires tectonically active regions. The phrase most countries cannot replicate signals geographic limitation. Quick recall hook. Location, geology. Geothermal needs volcanic regions. 48. Some energy experts consider burning wood and plant materials to be nearly carbon neutral because growing new plants recaptures the carbon dioxide released during combustion. However, environmental groups have raised concerns about expanding biomass energy production. What environmental problem could result from increased demand for biomass fuel sources? A. Increased earthquake activity. B. Depletion of underground water. C. Deforestation and ecosystem destruction. D. Accumulation of nuclear waste. Do you know the answer? Correct answer. C. Deforestation and ecosystem destruction. Explanation. Option C is correct because increased demand for biomass fuel could lead to clearing forests faster than they regrow, destroying habitats and actually worsening climate change. Option A is incorrect because burning biomass has no connection to seismic activity. Earthquakes result from tectonic plate movements, not energy production from plant materials. Option B is incorrect because while water is used in some energy production, biomass combustion primarily concerns forests and carbon cycles, not groundwater depletion issues. Option D is incorrect because biomass energy does not produce nuclear waste. Nuclear waste comes exclusively from nuclear power plants, which use radioactive materials for fuel. Biomass energy, burning wood and plant materials, sounds carbon neutral. Plants absorb CO2 while growing, release it when burned, and new plants absorb it again. Cycle complete. But here's the environmental concern. What if demand for biomass fuel exceeds the rate forests regrow? You start cutting trees faster than they can be replaced. Deforestation, habitat destruction, ecosystems collapse. And ironically, you release more carbon than you're recapturing because there aren't enough new trees growing to absorb it all. Biomass has nothing to do with earthquakes. Those come from tectonic activity. It doesn't primarily affect groundwater, and it definitely doesn't create nuclear waste. That's exclusively from nuclear power plants. The concern is specifically about forests and ecosystems. Here's a WGU C165 OA exam tip for you. Biomass energy risks deforestation if demand exceeds regrowth. The phrase increased demand for biomass points to forest depletion concerns. Quick recall hook. Burning trees faster than growing. Biomass risks deforestation. 49. Wind turbines generate electricity by using moving air to spin large blades connected to generators. Wind power is considered a clean and renewable energy source, but it has certain limitations. What is a significant disadvantage that affects the reliability of wind energy production? A. Wind turbines emit greenhouse gases. B. Wind is an intermittent energy source. C. Wind power depletes atmospheric oxygen. D. Wind turbines require fossil fuel backup. Do you know the answer? Correct answer, B. Wind is an intermittent energy source. Explanation. Option B is correct because wind does not blow consistently. Calm periods mean no electricity generation, making wind power variable and requiring energy storage or backup. Option A is incorrect because wind turbines produce electricity without combustion and do not emit greenhouse gases during operation, making them environmentally clean energy sources. Option C is incorrect because wind turbines simply capture kinetic energy from moving air. They do not consume or deplete oxygen or any other atmospheric component. Option D is incorrect because while backup power may be needed during calm periods, this is a consequence of intermittency, not an inherent requirement of turbine technology. Wind turbines spin when wind blows, generating electricity. Clean, renewable, no emissions during operation. The limitation? Wind doesn't blow constantly. Sometimes it's calm. No wind means no spinning means no power. This intermittency is wind energy's primary disadvantage. You can't schedule when the wind blows, so you can't guarantee consistent power output. Wind turbines don't emit greenhouse gases. They're completely emission-free during operation. They don't deplete oxygen or any atmospheric component. They just capture kinetic energy from moving air. The backup power issue is a consequence of intermittency, not a separate problem. The root issue is that wind is variable and unpredictable. Here's a WGU C165 OA exam tip for you. Wind's main disadvantage is intermittency. It doesn't blow consistently. The phrase reliability or consistent in wind questions points to this variability issue. Quick recall hook. No wind, no power. Wind energy is intermittent. 50. Energy experts recommend using a mix of different renewable energy technologies rather than relying on a single source. A desert region might prioritize solar power, while a volcanic island might emphasize geothermal energy. What principle explains why different locations should focus on different renewable energy sources? A. Only one energy type works in each location. B. All renewable sources work equally everywhere. C. Fossil fuels are better in certain climates. D. Renewable sources have location-specific advantages. Can you guess the answer? Correct answer. D. Renewable sources have location-specific advantages. Explanation. Option D is correct because each renewable source works best under specific conditions. Deserts have abundant sun while volcanic regions have accessible underground heat. Option A is incorrect because multiple renewable sources can work in most locations. The recommendation is to prioritize the most efficient option, not that only one can function. Option B is incorrect because renewable sources definitely do not work equally everywhere. Solar is less effective in cloudy climates, and geothermal requires specific geology. Option C is incorrect because the discussion concerns choosing among renewable sources based on location advantages, not comparing renewable energy to fossil fuel alternatives. Energy experts recommend mixing renewable sources rather than relying on just one. A desert region should prioritize solar. Abundant sunshine makes it efficient there. A volcanic island should emphasize geothermal. Underground heat is readily accessible. Why the different recommendations? Renewable sources have location-specific advantages. Each works best under certain conditions. Solar needs sun, wind needs wind, geothermal needs volcanic heat, hydro needs flowing water. Match the energy source to what your location naturally provides. It's not that only one type works in each place. Multiple sources can function almost anywhere, but some work far better than others depending on local conditions. And all renewables work somewhere, they don't all work equally everywhere. Here's a WGU C165 OA exam tip for you. Different locations should prioritize different renewables based on local conditions. The phrase different locations or regional advantages signals location-specific optimization. Quick recall hook. Match source to location. Each renewable has geographic sweet spots. You've reached the end of our first question set. For the free complete exam preparation, visit our website link in the description, where you find thousands more practice questions and comprehensive study guides. Thanks for studying with us today. See you in the next video.